Well, first, let me thank you again for this amazing conference, the chance to be here, listen to all of these interesting inputs, and also present myself. Today, I will talk about a topic that has already been alluded to quite a few times during the day, and that is what kind of lessons we can draw from Ukraine's experience in the use of UAVs during the ongoing conflict. And it's a quite challenging topic, both because of the scope and because it's a disruptive technology that is still evolving. But I will try my best to summarize first what I would call conventional lessons or provisional lessons that we can draw from the conflict. So the first is that heavy UAVs, medium altitude, long endurance, male UAVs have proven to be quite vulnerable. This is now commonly accepted, but if you go back a few years, these UAVs were actually the main focus of Western countries procuring their own UAVs. Now they have a few issues when you talk about integrated air defenses. Small UAVs are currently the main focus. So you, of course, all know the FPV drones are the most numerous, quadcopters, loitering munitions, one-way attack UAVs. And what the war has also shown is that these systems are not only cheap and affordable, but they can be used on absolutely massive scales. When we talk about Ukraine, we talk about several dozens of thousands of combat missions per month. We talk about hundreds of thousands of reconnaissance missions per month and requirements for small UAVs that go up into the millions. Now, one of the things that has already been mentioned here is the really short development cycle. So you might develop a product and within 2 weeks, you might not be on the top of the technology anymore. You might be able to adapt it. You might not be able to do so. So this is a big issue and has major implications for the way procurement and development works. We have seen that UAVs are very effective strike weapons, but that they are also force enablers, that they're force multipliers, that they can be used to correct artillery fire, to direct other effectors onto the targets, that they can be used to build a very, very fast kill chain, but that in order to fully leverage their potential as enablers, you also need to integrate them into a robust command and control infrastructure, so that all of this data generated by the UAVs can actually be leveraged for effect. And we've also seen that there's a very critical requirement for counter-UAV solutions that should be distributed to the smallest tactical units. We've also seen that the electromagnetic spectrum has become absolutely crucial when you talk about countermeasures, electronic warfare, jamming, spoofing, and whatever is out there. So these are all the, I would say, conventional lessons, which you've probably heard quite a few times by now. And the challenge is, how does the West adapt? I think one of the prime challenges is that the technology, as disruptive and fast as small UAVs, for example, is very ill-suited to the kind of defense infrastructure that we have, the defense companies. I once had a very memorable chat with someone from a large European defense company, I won't name it, and I was asking, so when exactly are we going to have our German version of the Shawhead, a one-way attack UAV? And he told me, you know, we're this company, we only build expensive things. We can't build it. So you have companies that are geared towards the production of highly expensive, exquisite systems that are only procured in small numbers. That's difficult. Of course, you can always have new actors, defense startups, and these have been springing up in the drone field in numerous European nations. But then again, these face challenges. So who do you produce for? When you have a technology as rapidly as this one, stockpiling might not be a good idea. If you buy 1 million FPV drones, they might be outdated 2 years from now. What are you going to do? Every startup is facing the valley of death. They're facing cultural and also in many cases legal hurdles when they're working in the defense sector. The requirement for robust supply chains is another issue. We don't want your drones to be dependent on parts from China. And another really critical issue is the lack of real-world feedback. Another memorable conversation I had was with a Ukrainian drone operator who was sitting in the room with another representative of a very well-known Western company who had just advertised his loitering munition solution, very exquisite, very famous. And the Ukrainian operator was saying, you know, all of these renders and spreadsheets are fantastic, but actually we tested it, an FPV drone for $300 is much better. I'm sorry, but that's the way it is. And when you have a technology where it's not even about the technology itself, but the concept of operation, the very ideas of how systems work are not yet proven, you need reality checks and you need them fast. Then another issue that we've seen in Ukraine is the need to establish quality control mechanisms that you can activate in wartime. We talk a lot about the shortages we have and how we need to have mass production. But once you enter armed conflict, you might actually have the opposite problem, that you're swarmed with different UAV designs provided by companies from all around the world, and lots of them might not be up to the task. We all have a manpower problem in our countries, that probably is fair to say. And do you really want to use your valuable soldiers to operate equipment that is not up for the task? So the Ukrainians have established very strict testing procedures now, where they really want to vet the material that is being sent to them, and Western countries would need something similar. Another issue, of course, is that the whole defense procurement network is tailored for high-value, exquisite, high-tech purchases. So, for example, when you order a new fighter jet, at one point you want to freeze the requirements and freeze the specifications of the system, because otherwise you will get the equivalent of mission creep. You will get a very expensive system. If you have a UAV, that's not a good idea. I mean, with a conventional procurement process, you might get a system that is already outdated 2 years after you ordered it. And finally, there's the question of how are you going to coordinate across branches of a military when you have so many technological overlaps in many fields? Well, there are a few potential pathways. One very interesting is collaboration with Ukraine or even joint development of UAVs. There you have the reality check. You have a market for them. So new companies can actually survive. We're seeing that a lot in Germany as well as other European countries. Just yesterday, there was a huge announcement by the Dutch that they want to invest, I think it was several hundred millions into joint UAV development with the Ukrainians. There's another interesting approach that is component stockpiling. So you don't stockpile the systems themselves, but key components, electrical motors, for example, that won't get outdated as quickly as others, so that in times of crisis, you can actually manufacture them really quickly. There are questions about new approaches to procurement. So, for example, when your traditional procurement agencies that have been designed for naval vessels, fighter jets, or main battle tanks are insufficient, can you build a new procurement agency that looks more like the kind of agencies you use to procure IT solutions, for example, where you always have rapid turnovers and rapid technological developments? Is that a possibility to become more agile? And finally, there's also the question of more flexibility when it comes to regulations. Again, this is a disruptive new technology. This is not incremental improvement of existing technologies, like a new fighter jet. So you really have to get the reality check. And how do you do that? By experimenting. When I talk to people who work in the UAV industry, one talking point that gets repeated over and over again, and interestingly enough from both manufacturers of smaller and larger UAVs, is we need to get out of the phase of renders and strategy papers. We really need to test these things. And a lot of times in Western countries, the regulations are incredibly strict. I can tell you the act alone of flying a large UAV in civilian airspace is a giant bureaucratic hurdle. And of course, the question is, could there be new approaches to coordination between branches? We've seen Ukraine having its Independent Unmanned Systems Forces Command. Is that a solution that could work for other countries? We had similar proposals in Germany who got rejected in the end. But in the end, it's something to think about. But then I think one very important question here is, to what extent can we actually apply the lessons from Ukraine? And I think we have to be aware of the fact that what we're seeing in Ukraine now is a very specific context, a very specific type of war being fought by very specific actors with certain limitations, with certain capabilities. And that war is being fought in a very particular state of technological development. At the same time, we have very incomplete information about what is going on in many cases. There are still lots of questions. You have lots of material, of course, out there, but lots of questions as well. So in the end, what you get is an incomplete snapshot. And there's a bit of a danger if you base all of your ideas for the development of your own UAV forces on that particular snapshot. And I want to give you just one example, large UAVs, and in the case of Ukraine, the Bayraktar TB2. So when you look at the Bayraktar TB2 and you looked at conventional wisdom, and let's say 2019, people would have told you, oh, you know, it's a heavy UAV, it's quite slow, it's easy to defend against. It's great to chase rebels, yeah, or terrorists, that's okay, but against the conventional military, it probably won't work that well. Then you had the use experiences in Karabakh, in Armenia, and of course also in Syria and Libya, and people were saying, you know, the Armenians were not prepared that well and they are not as capable, so perhaps these things can be successful. Then you had the war in Ukraine starting, or the full-scale Russian invasion of Ukraine starting, and people were saying, the conventional wisdom was, you know, it might have worked against Armenia, but the Russians have this history of electronic warfare and integrated air defenses. It's not going to be very effective. Then the TB2 was incredibly effective for the early stages of the war. Then Russia consolidated its air defenses and it suddenly stopped being effective. And now people say, oh, it's only used in limited reconnaissance roles. But then again, if you talk to Ukrainians, you realize these limited reconnaissance roles are still incredibly valuable. So you can do standoff ISR using electrical optical seekers, you can do maritime reconnaissance. So it's still an incredibly useful tool. And that's the current state. Is it going to change again 6 months from now due to technological development? We just don't know. The same applies to focus. So we talk a lot about the Ukrainians, but there are other UAVs around that we don't talk about as much. When you look at NATO AGS, Aligned Ground Surveillance, you have Global Hawks operating using extremely long-range sensors, synthetic aperture radar, monitoring Russian movements in Ukraine. And of course, that information feeds back into Ukrainian war planning, and that seems to have been very successful, but is not talked about very much. You have Russia resuming operations of its Orion heavy UAV in Kursk at the moment. Why they're doing that, what the exact conditions are. Probably weak Ukrainian air defenses have something to do with it. So again, that conventional wisdom is again being challenged. And then, of course, Ukraine is limited when you talk about what they have in stock. So the Bayraktar TB2 is actually a very... People always say it's good enough for many tasks, but you could have completely different capabilities. For example, airborne early warning that stays persistent and can be used to detect low-flying targets like cruise missiles or Shahhed UAVs. True maritime patrol UAVs. These are all capabilities that might be incredibly useful, but are just not there, so we can't really evaluate them. And another question, of course, is, would NATO fight the same way as Ukraine? When you look at the Ukrainian position, they just have no chance of achieving aerial supremacy. As much as I like the F-16, that's probably just not going to happen. And because of that, a lot of times UAVs are used to compensate for the lack of air superiority by striking targets deep inside Russia that another military might try to attack using JDAMs, using manned fighter jets. But the Western way of war has always been to achieve aerial supremacy first and then fully leverage that. And if you look at a lot of UAV developments in the West, it's actually not intended to compensate for a lack of aerial supremacy, but as a way to achieve it, which is a completely different logic. So you have projects like, you probably know the concept of loyal wingman. You have very capable UAVs, much more expensive, much more sophisticated than the ones that we see currently used in conflicts around the world, cooperating in conjunction with manned fighter jets to overcome integrated air defenses of the adversary. So you have a completely different approach, but then again, there might be overlaps. So if you want to achieve aerial supremacy and overcome ground-based air defenses, you might be able to do that with an incredibly sophisticated UAV, operating with an F-35. You might also be able to do that by just swarming your enemy defenses with incredibly cheap drones, or doing both at the same time in a high-low mix. So again, these are all questions that we just don't have clear answers to at the moment. And finally, will NATO engage in the same type of conflict as Ukraine? Right now, we're having an all-out existential war. But we've heard before, in the future, NATO might be engaged in a different kind of conflict with Russia. You could say we are already in a form of hybrid conflict, hybrid warfare. There might be a limited conflict. I mean, I'm looking a lot at the Middle East, and I think that's quite interesting what you see there. When you look at Iran's strategy, that's now falling apart, but before was basically saying, oh, we're willing to escalate more than the adversary, and we're going to leverage step by step through limited application of violence, through missiles or UAV strikes, for example, that are more kinetic symbolism than real warfare. Could something like that happen? And if you have a situation like that, what role could UAVs play for both Russia and the West? I mean, UAVs are great because you don't lose anyone when they get shot down. The West's weakness, so to say, is that we really care about our soldiers. We don't want to risk their lives. But sometimes you want to show the flag somewhere. You want to show your presence. You want to show that you're not intimidated by a few old flankers. UAVs can be useful. But then again, UAVs might be useful for the adversary as well. When you look at, again, I love looking at the Middle East because so many of the things we saw in Ukraine later, we first saw on a small scale over there. UAVs as sabotage weapons are incredibly efficient. You can greatly increase the efficiency of your sabotage team by giving your sabotage team a standoff weapon. You can do the same for ISR and reconnaissance, and that might already be happening in parts of Europe. So you have all of these new applications of UAVs in conflicts other than all-out war that we don't even think about that much at this point in time. And to end it, I would say, when we look at the lessons learned from UAV use in Ukraine, the big takeaway for me is that you have an extremely rapid development. You still have basic concepts not being clearly defined. You have rapid shifts of technology, doctrine, etc., etc. And the most important thing is really to create an ecosystem where you can react flexibly to whatever challenge arises, and to basically keep your options open and not say, okay, we've seen this works in Ukraine, this doesn't work, now we follow that step by step, but to be flexible and have basic capabilities so that you can rapidly adapt in times of crisis. And I'm open for questions. Thanks so much for your attention.
Thank you very much. We actually have one question. In your opinion, how will the artificial intelligence change the warfare and maybe UAVs?
I kind of expected that question, and it's a really tricky one. So I would say artificial intelligence, a lot of it, it's always the question, what do you define as artificial intelligence? There are features of land attack cruise missiles that are kind of artificial intelligence that have been used since the 1970s. And I would say we're going to see a lot of artificial intelligence in very unspectacular roles, just improving flight performance, improving accuracy during the final descent of a suicide UAV, for example. These are the things we're going to see. Personally, I would say the big advantage of AI will not so much be a complete automation. I think people will be quite reluctant to hand over full control, even though that might have happened on small scale. I think we will just have AI to dramatically increase the efficiency of systems. If you imagine you have an integrated command and control system to which all of the information by UAVs is fed, and then you have automated detection of certain adversary capabilities, and then it allows the operator to just make decisions much more quickly. I think that's next step, but we're still a bit away from the completely autonomous swarms as we sometimes imagine them.
And I believe the similar topic would be swarm tactics.
Yes, I would say so as well. So what we're already seeing, of course, is the attempt to overwhelm enemy defenses. But in terms of real coordinating swarms, there might have been some experimentation, but we're still a bit away from that.
Thank you, Mr. Hinz.
You're welcome.